Section 10.10-2 is with respect to infinite limits and limits at infinity. Material that you already have done back in your pre-calc. We just didn't call it that at that point in time. First one I want to look at is infinite limits and vertical asymptotes. A vertical line, x equals a, is a vertical asymptote of the graph of my function, y equals f of x, if f of x is going to positive infinity or negative infinity as x approaches that value from the right-hand side or the left-hand side. Think of your vertical asymptotes. This is where you had a break in your graph and your curve snuggled in to the asymptote on both sides. There's some good examples you need to see in the book. Example 1 on page 491 and example 2 on page 492. So go and look at those. Stop me for a few minutes. Go look at them and see if you can recall your vertical asymptotes. And also we looked at horizontal asymptotes. Now for any function f, if the limit of my function as x goes to positive or negative infinity, so as x gets infinitely small or infinitely large, my function levels off. And if it gets close to a particular value, then this line, y equals L, is considered a horizontal asymptote for the graph of f. Now special limits at infinity, for n, a positive real number, if you take a limit of 1 over x raised to whatever power you want as x goes to positive infinity, this thing gets smaller and smaller and smaller, and technically it goes towards 0. Likewise, if n, a positive real number, you're taking the limit of 1 over x to the n as x goes to negative infinity, it also goes to 0, provided that x raised to the n is a real number for negative values of x. On page 496, it refers to the theorem referring to this horizontal asymptotes. Now, before I look at this any further, remember how we did horizontal asymptotes in your pre-calc class. We would look at the largest exponents and we would get the coefficients. So in this particular problem, my horizontal asymptote should be y equals 2 as x goes toward infinity. Now, with respect to this last bit of information, the limits as x goes to positive or negative infinity, the trick on these is to divide numerator and denominator by the largest power of x. So my largest power, you look top and bottom, is x squared. So if you divide every term by x squared, this will give me 6. This reduces to 1 over x. This is minus 2 over x squared. This reduces to 3 plus 2 over x minus 5 over x squared. Now with respect to that theorem that I had prior to this, any of these that have x in the denominator, they head towards 0. So if you simplify, you end up with 6 minus 0, which is 6, 3 plus 0 minus 0, which is 3. So 6 over 3 is equal to 2. That's how we found our horizontal asymptotes. Back in pre-calc, we didn't do this, but because of calculus, we could do that. So you might need to recall how you found horizontal and vertical asymptotes. I have another Camtasia video for this section where I just look at examples. Okay, so that should be the next thing that you look at, and then you go and do the homework. Thank you.